It's the time to start our second session by HAC Professor Dr. Chandan Kumar Chanda sir. May I have the honor to read his biodata. Dr. C.K. Chanda received BE in Electrical Engineering from RE College, Durgapur, M.Tech from IIT Kharagpur and received PhD degree from the Department of Electrical Engineering, BE College, Shibpur, with specialization in power system. Dr. C.K. Chanda has over 33 years of teaching and research experience in the diverse field of power systems engineering and almost 5 years of experience in industry. He is a recipient of Tata Rao Gold Medal. He is actively involved in various research projects funded by centrally funded organizations like DST UGC. He has published 160 research articles in reputed national and international journals and conferences, including 50 research papers in SCI and Scopus Index journals. Dr. Chanda is member of editorial board and guest editor of numerous reputed journals. He has authored and co-authored 9 books in reputed publishing houses like CRC Press, Tata McGraw-Hill, PHI, Springer, etc. He has contributed 21 book chapters in international proceedings. 13 research scholars have got their PhD degree under the esteemed supervision of Dr. Chanda. Currently, 7 PhD students are pursuing under him. He has visited different foreign countries including USA, UK, Australia, Japan and China for academic purpose. He is a senior member of IEEE USA, member of IIT UK, fellow of Institution of Engineers, chartered engineer and life member of IIEST. Dr. Chanda was a former lecturer in Electrical Engineering Department of National Institute of Technology, Durgapur, and presently working as a professor, higher administrative grade in the Department of Electrical Engineering, IIEST Shibpur, India. His present research area includes smart grid, power system resiliency, solar forecasting, distributed generation, power system stability, voltage stability and security, renewable energy, etc. So please sir, now stage is yours.
Mitigation and challenges and solutions. Already my colleague Dr. Dey touched upon a little bit about this renewable integration and challenges in the beginning in a very lucid way. But we are all talking about renewable energy nowadays. In fact, in almost renewable energy, why renewable energy, why we are not interested in the classical kind of energy available, I mean this coal-based thermal generation. These are all general kind of things. You know, even if our 9th and standard students are studying, we have to take care of our climate. The climate issue is global warming, as well as the reserve sources are depleting in nature. So a lot of issues are there, and for that there is no other alternative until unless you go with the renewable sources. The renewable means the source which is infinite in nature, in mathematical speaking. It's not infinite in true sense, in mathematical sense. We talk solar energy is infinite, sun's energy, but no, it's already calculated, maybe it is valid for 10 to the 3 billion years after that there is no sun, no energy. Anyway, in a human time scale it is infinite. So, let me start with the basics funda, but before that let me interact with my participants, as because it is a faculty development program. I know a teacher is teaching the teachers. So that is another kind of teaching, possibly this is known as micro teaching. When teacher teaches a student, that is a teaching. When teacher teaches teacher, there is a micro teaching. And micro teaching means a kind of interaction, so it does not mean that sometimes your knowledge in that domain might be more than me, and some kind of flow from both the directions, the way the smart grid acts, two-way communication. So the question is, how many of you from the power system background or high voltage engineering background? I think this mixture is heterogeneous in nature. Maybe few from, I know Choiti is from control, if I am not wrong. I know this data. Sarat from power system, I know. So others are, because this topic is completely focused on power systems, not that much control and all that. So that is the thing. That's why you want to get this idea from your side, exactly. Or otherwise, let me talk in a very generic fashion so that you could understand a little bit. I have not taken the mathematics. The moment I came to know that my delivery after lunch, so intentionally I have avoided mathematics. I will go to the whiteboard. In fact, that I have not inserted here, but I have to explain the basic part of that group of and all that. Show these are so. The basics of our systems, it's not that this 1880, if we look back the history, Thomas Alva Edison and DC power and the side by side, Westinghouse House, Tesla and DC power, that probably the current war, that the thing. From there we know the structure, the basic power system structure, we have to check. It's not that we are talking about 2024 January and the structure is different. With one picture I will try to explain what is the change in the communication sector and what is there in the power sector. In 1880, when this thing started, generation, transmission and distribution, and at the end the customer sale, and we talk about 2024, same thing. We have to generate something, something in the sense that power. We have to transmit with a good efficiency. Then we have to distribute that power to the distribution sector, where we use the renewable energy. We cannot connect renewable energy to the transmission sector. And then the power will automatically go to the doorsteps of the customers or consumers. So that's the concept in 1880, and this is the same concept what I am talking in FDP in second lecture in 2024, 15 January, same. So what the hell we have done for last 120 or 25 years? And what exactly we are doing in that direction in the power systems? Or what are the limitations of this kind of power system? So these are nowadays the new research domain, and we will focus on those different types of topics or the catchy words, wherefore we can extend your idea and go into research. So basics of our system, let me read out, all these things. The main role of grid is to generate electricity. You know exactly what you mean by grid. Let me take a small example of a grid. Grid is basically a kind of a university. So Knockout is a university, and under that I am not quite sure, maybe 100 engineering colleges are connected with Knockout. When students will come out, they get the certificate from Knockout, not from BCREC college. Until now, BCREC is having the autonomous structure or self-funded university. Grid is like that. I can generate power, DBC can generate power, but that power we cannot utilize until and unless we put to the grid. We have to put that power into the grid. And grid, according to the load demand or load forecasting methodology and all that, they have some kind of 15 minutes load scheduling idea, and accordingly they distribute the power. They are having kind of grid protocol nowadays. We follow 15 minutes scheduling structure is there. Those are from the direct power sector side. Nowadays we follow in our country 15 minutes scheduling. And they dictate from the protocol side or Power Development Corporation side, 15 minutes, this is the requirement. And they take out from the grid. But we generation people is bother, whatever you generate, put it they take it. But the difficulty in this grid is this nowadays, they have given a lot of grid codes, and I hope if you are from power system, 2003 Electricity Act in our country, whatever I describe, Even though it is generic, but I try to focus from our country's perspective, and that will help a lot to attack the real life problem. So after 2003 Electricity Act, we faced number of times complete blackouts in India, even 2011 if I am not wrong, 30th and 31st July. So even though there is a strict Electricity Act rule in 2003 implemented in India, still we used to face blackouts on a regular basis. Even though that time there is no cyclone and super cyclone like Amphan, yes, kind of things not there. It's a recent phenomena for last 2 and 3 years. Should they have gone for a coding? The coding will go for the dress coding of BCREC college or dress coding of the civil, they have gone for a special kind of coding for grid. And you know we are having the 5 grids, and all the grids are connected at 50 Hz. So one country, one nation, one prime minister, one president, and one frequency 50 Hz is the concept in India. So those 5, but 2 or 3 years back it was not that. South India side is completely different, and they used to connect in back-to-back mode, asynchronous mode. So source are connected in 50 Hz and other was not that. But now after this 2017 onwards, if I am not wrong in the statistics, so now you operate in the same frequency 50 across India. But the difficulty of this grid is this: if you go into the little deeper into the definition of grid, how do you define this grid? Grid is basically we consider as a infinite source. The moment you talk about infinite source, what exactly we mean by infinite? Mathematically it's kind of infinity sign in the grid, or some kind of infiniteness has come into the grid. What exactly it means? It means if there is a fault in a power system, the grid should be designed in such a way and its reactance value should be such that there will be no voltage fluctuation into the grid. Voltage may fluctuate in the generation side, it doesn't matter, but grid will 1 angle 0 only. That is the basic design philosophy. And the thoughts of the student, what do you mean by bus? PV bus, E bus, this bus, that bus, and infinite bus. So they cannot, sometimes they cannot produce the correct answer. Infinite means only we put emphasis on those 2 parameters. Anyway, by default voltage is fixed in a grid, but very difficult to maintain that the issue, that the short circuit ratio issue in a grid. If the grid itself is a weak grid, if the grid is not a strong grid, and at the same time, if there is a small fault, any kind of fault occurs in a larger power system. If there is a large fault in a small interconnected system, it doesn't matter much. It can be tolerated by a weak grid too. But if it is a very strong grid, but a small voltage occurs in a large interconnected area, large interconnected and in one part of my delivery it is there, and small interconnected, I mean, so the eastern part of India is connected to the northeast part of India. So northeast India, that network is comparatively much smaller compared to the eastern part. So if there is a large fault comes in the eastern northeast part, that doesn't matter much. But if the small fault comes in Bihar or in part of Bengal, that's a huge problem. It might happen that problem may be reflected to the northeast part also. So that's the issue with the grid. So that grid we developed long back, 120, 125 years, that Thomas Alva Edison, the man who gave the concept of grid, and then came Tesla and all. So that grid, this is the biggest issue, the grid. And the limited one-way interaction that this limited one-way, this power is a vertically integrated system, generation, then transmission, then distribution. Whatever will generate, we have to consume it. There is no other options from the customer. There is no option in the sense customer is ready to pay the bill either at the end of the month or in quarter bills, especially in the state utility. They go into that's the option. They have to pay the bill. Or in evening there is no power, he cannot communicate to anybody else, he cannot go with any kind of argument, debate. He has to accept and absorb that idea. So it's a one-way communication and the complete communication from generation to the customer side. So these are all limitations. Then the concept has come smart grid. I will come into later in detailed elaborations of smart grid. Professor there touched upon that issue. The smart grid introduces two-way communication between the intelligent. That's the beauty of smart grid. Sometimes the student asks, why is that smart grid? Why not we can call it as intelligent grid rather than smart? But there is a small story behind it. Let me tell you, I am not sure about that story. I got from a journal and I got one of my senior professor, yes please, from Dr. S.N. Singh. I got this information. The smart grid should be replaced by the intelligent grid, but let me put that question the other way around. Sometimes we say that girl is a very smart girl, that boy is a very smart boy. So should I replace that thing, he is an intelligent boy or he is an intelligent girl or a smart? What does it mean? If I pose this question to you, what should be your answer? To a boy or a girl, forget this power system, will come later on to an hour's duration. What should I say, intelligent or smart? Smart means it covers a lot of things. Intelligent means maybe from her or his academic point of view is too intelligent. His absorbing power is very good, but it does not mean everything. Smart means it can, apart from an intelligence level, she is having other lot of issues, what the managerial issues are not there with the other guys or other boys and girls. That's the smartness. So this grid is appropriated term by the President of USA, Barack Obama, in his first presidential address, knowingly or unknowingly. In his first presidential address, he uttered this word smart grid, and from that time on, IEEE people of USA picked up this word smart grid. Then we the people, UK and Asian people, we are very experts in copying and all that. From that day on, from Barack Obama's time, they have started saying smart grid, smart grid. Even Dr. There has touched upon that word smart grid in the first half. So that's, but I don't want to go into that debate whether it is smart or this, because smart grid covers a lot of issues, advanced sensing devices and all that. So that's required developing, and why again it should be smart. In the meantime, there is a huge amount of development in the material side, nanomaterial, a lot of material side and development in last few years, 7 or 8 years. Communication has developed a lot. It is unthinkable development in the communication sector. There is no doubt behind it. So communication sector is here. I am not a man of communication, but still a lot of communication, means Bluetooth communication, Zigbee communication, lot of communication IEEE protocols are available nowadays. So that communication protocol, if you club together with the classical traditional grid, the grid has to be smart. I don't want to mean smart grid means power generation will not be there, transmission line, everything should be there in the core part of the smart grid. Professor, they touched upon synchro phasor or phasor advancer. It does not mean we cannot leave the SCADA. SCADA, even 15 years back, SCADA was here. So SCADA should be inside the heart. The heart of the power system is SCADA. On the top of that layer, the artificial intelligence, AI and ML has introduced and has made the whole thing as synchro phasor or phasor advancer or that kind of thing. So it does not mean generation will not be there, transmission line will be not there, only smart grid will be there, that won't serve the purpose. So that I want to mean. Someday it get covered. Sir, nothing will be there, only smart grid will serve the purpose. That's why, I don't think that was certain purpose. So that's required developing the network automation, control and different tools which will work together to make the grid more efficient, reliable. Nowadays we are replacing this word reliable, rather we have to make this grid resilient. We are trying to shift this term from reliability to resiliency and much more. That is really very, very important issue nowadays. But let me tell you, during my delivery, any time, any moment, any kind of question, it comes in the back of your mind, you feel free to ask me, and I am happy to answer this question. Which kind of this FDP I personally feel teachers, what's a teacher? It's not that UG and PG students are there anytime. I'm happy to answer these questions. Better go with interactive type of things. If even in doubt or any kind of questions you can put me. It's not that I will be disturbed reading the delivery. Sir, you are going on delivery, if I put, doesn't matter much. Okay. So traditional power system, you know, but let me go through as I have developed this, so I have to go through. The present infrastructure is overstrained and inter-region power transfer is limited. That's true. Only if anybody is there from the practicing engineer side, they know our power system, especially the eastern part of India, is really overstrained. Can you explain me how the power system is overstrained because of the load car? In fact, we got this issue 4 or 5 years back, and from the CSC people and state electricity board people, they clubbed together, they came to IIT Kharagpur, they offered this issue with some good amount of package, but they didn't able to solve the problem. Then went to chronologically, as per the rank of the institution, they went to Jadavpur. Jadavpur people took that issue, and then again they thought that we'll be able to solve the question of 10 lakhs. We can solve the issue, we'll get 10 lakhs, and anyway they failed to do it because of this overstrained and inter-region power transfer issue. Then they thought that B college is not far off, so let us go. A lot of stalwart power system professors said they are going from Banerjee, Yoginandon, C.K. Chanda, let us go and approach them, and they will solve the problem. We took this problem in the name of 10 lakhs. After 3 months, we feel like anything, and gone. Only a few cups of tea and all that. The question is, where is this overstrained and inter-region power transfer? Because of the law. In our state especially, this issue may be a political issue, but I am not going into political side, completely this side. In the morning, what should be the pattern of the load? Very rich. 10, 10:30, 11 o'clock, the load pattern is slightly more, I mean, trying to going to the peak shine. Rather, it is a kind of solar generation car, I mean this PV kind of car. In the morning, very late, and then gradually is going to the peak at 12, something like that. But it's not exactly PV car, and then it takes a steady value. But suddenly evening, nowadays the residential load is very fair enough. So the residential load has become tremendously high. Again there is another peak comes in the evening shine, and after 10 o'clock finished. So 10 to again 7 AM or 8 AM, almost no load parallel to the base load. And say nowadays almost all the alternators in the design of 500 megawatt, mostly you take power from NTPC and NHPC, and their alternator design is 500 megawatt. Say, for example, say our requirement is 1000 megawatt. It's not exact data. For simplicity's sake, I am taking an example. What is happening in our state here and our eastern part of side. Say 1000 megawatt is required in the peak hour. In the morning hour, we require only 250 megawatt. Every alternator can deliver 500 megawatt. Say KTP, they are having 6 into 210 into 2. That combination is feasible. How to mitigate this 1000 megawatt power in the evening time and 210 megawatt power in the morning time? And in night time, sometimes the power goes down to 50 megawatt only. Just for example, say maybe it will be multiplied by 100 without the quantity. How to solve this issue? Alternator or synchronous generator is not an ordinary switch of a house. Power is not available, you put the alternator off. When power demand is there, you put the alternator, it is not there. To start the thermal power plant, from the cold state, it takes 8 to 10 hours. In hot state, it takes around 4 to 5 hours. It's not an ordinary switch of a house or circuit breaker. You put it on and put it off. So this 5 or 6 hours is a very challenging issue. And they came to us how to solve these issues, that these load issues and these alternator issues, how to mitigate this problem. If you can show any path, any way, you might be a part of the problem. So, haye geche puje den 10 lakh give. But we'll do that. Morning 50 megawatt 100, evening 1000. That's why the issue is our present structure is really old and aged, at the same time overstrained and interregional. That's the biggest issue, and every evening time, those who are working in PDCL, in fact I met one of my classmates, he is the managing director sector of PDCM. That's the biggest issue nowadays in every meeting they face. Cannot fully support the integration of renewable energy. That is very good. Renewable, how much we generate in the terms of megawatt, gigawatt only, especially in Bengal, in Sundarban area, that from the solar side. And here the generation level is gigawatt. How to connect gigawatt to the megawatt and kilowatt? It's a very challenging task. And that we have to connect in the distribution sector also. We are talking a lot of things we can talk about. Renewable energy is the only alternative, only this will be there, everything is okay. Textbook language, but they are the practical issue or the practicing engineers issue. And probably you have seen my topic, the challenges of renewable energy. I am not going to talk in favor of renewable energy, rather the challenges. And of course, if there are challenges, there are some remedial solution, and I will try to write a prescription for that, how we can mitigate that issue a little bit. Major source is fossil fuel, of course, that the biggest disadvantage, because fossil fuel means it's completely finite in nature. Maybe after 50 years, 60 years, 100 years, 150 years, in different magazines it comes in a different years, it will be depleted, it will be an end because the source is finite. This is one issue, and another is the global warming, climate issue, environmental issue. So climate issue, depletion issue, finite issue is the biggest issue of fossil fuel. If we consume, this world is not for next 100 years and 150 years. This is for maybe for another 1,000 years. So next generation, where they will go with the power? So fossil fuel, we have to think in a different way, is a major concern. Efficiency of power transmission is the biggest issue in your country. Very, very poor, in fact, compared to other countries. Because they go with a hybrid kind of transmission, possibly, in USA, in fact, not this year, sometimes I do the mistake, last year I have been in USA with Sanskrit. They are having a mixed kind of transmission line, partly DC and partly AC. I have never seen in my life. Is it purely AC or purely DC that I have seen? But they are the mix, that gives a very good efficiency in USA, especially the western part of US and Texas part. They are doing, only in USA they are having that combination of the transmission line with better efficiency. Almost zero customer participation, that I already explained, because of one-way communication, customer cannot participate here. Low billing and quality efficiency, low billing because not in our country, in fact, in a developing country or underdeveloped country, theft is a very big issue, and in such an issue, a textbook is available of 400 pages of theft on electricity. That's the biggest issue. 400 pages textbook is available on theft issue of electricity. That's the issue. And that we know also, apart from technical loss in transmission line and commercial and distribution line, there is a commercial loss, and that commercial loss is the low billing, of course. They are generating power by burning coal. If they cannot collect the bill, how do they manage the scenario? That's the issue. And collecting efficiency is very, very poor. That I wanted to be. This is a very interview. Wherever I go, I kept this slide intentionally, and that's very interesting. I enjoy this slide. All technical things going from the morning, you feel bored after the lunch, so I have a lot of pictures. So let it be the kind of moving, I don't think. See, Alexander Graham Bell was somehow transported to the 21st century. First reading out, hopefully you'll get this from this. He won't begin to recognize the components of modern telephone, smartphone, texting, cell towers, etc. While Thomas Alva Edison, one of the great key early architects, would be totally familiar with the grid. What I mean, that would be much more clear in the next slide. This normal phone, if we could have bring back Graham Bell and ask him what is this, he would identify, this is the thing I have invented. But if you ask Graham Bell, what is that, he won't be able to identify this. He won't be able to, this phone, you can text, you can talk, you can send the message, you won't be able to identify. And this happened only in the last 15, 16 years or 20 years maximum. But if you consider this normal phone is a grid, classical power grid, and if you ask Thomas Alva Edison, I can identify this is the grid. And again, if you can bring back Thomas Alva Edison and go to Devishi, one grid is there. I know NTPC big grid is there in Durgapur. And so it can we identify, oh yes, this is that grid identity. So that change. Then our question, not my question, your question definitely, in last 20 years, if this telephone can become this telephone, why this classical traditional grid cannot be converted to a smart grid? Why Thomas Alva Edison is able to identify 20-24 people? Yeah, this is the grid. I made it 130 years back. He easily identify it. We have to change it. The danger are not follow whether there are advantages. I hope I am able to make you understand the difference between the communication sector. This is one kind of communication, where communication. This is another kind of communication, unthinkable. Just by a click, you can reach anywhere, any place, no issue. But as far as electricity is concerned, still we are in that age, 1880 age. So the question is, how to make it? Obviously, the next question is, if the fossil fuel is finite in nature, depleting in nature, lot of environmental and climate issues. Climate issues I am not going to explain. Every year in the month of May, you are going with a super cyclone. Nowadays, the storms is a different type. A super cyclonic storm comes in a fashionable name. Yes, Ampan, different names. They decide. I do not know how they decide the name. So we have to depend on this renewable energy. The renewable energy, lot of advantages are there. Clean energy, of course. And let me tell you regarding this point, I am not going to detail. Sometimes we say clean and green energy, but renewable energy is not green at all. It's a clean energy. Sometimes the question of an interviewer question, this solar energy, green energy, or clean energy, they say clean, green, both are same, sir. Both are everything is same, sir. Everything, sir. We call it clean and green. What is a clean, not exactly green? There is a difference. Clean energy. Obviously, chief, no doubt behind it. Once you install this solar panel, it is almost like advertisement of Honda, fill it or set it and forget it. Once you put it, this panel, forget for 25 years, the sun is available, the weather is not cloudy like today, no issue. You will go on generating power, and next day, 16th January, sun will not come to DGP and ask, pay the money, yesterday gave a huge amount of radiation to you. It's absolutely cheap. Nobody is there to claim that money. Where coal is involved, they're different issue, they're different story. Sustainable, obviously you want to run down. We are all talking about sustainable energy. Maintenance requirements are low. As far as it's not exactly true. As far as the solar energy is concerned, maintenance is less, because a lot of static devices, solar panel itself is a static device. But as far as the wind energy is concerned, it is not that. Because some rotating, it's a variable speed machine is there, you know, double feed induction, generator, DYG, and the question of maintenance is there, and especially much more maintenance is required in double feed induction generator, because there is a variable kind of generator, it's not a singular generator. No pollutants into the air, obviously, of course, the health benefit, I am not going into details. I can go on delivering lecture on 1 hour for health benefit. We have seen what exactly health benefit means. In 2019 December starts corona for the whole globe for almost 2.5 years and 3 years, and we know what exactly is virus and all that, we know it, and collapse the whole globe for that. No greenhouse gases, environmental benefits and others. So there are challenges. All those are the advantages and in any textbook you find. But what are the challenges are there? So a lot of challenges are there in this renewable energy. We can talk, we can penetrate, integrate renewable energy into the classical grid. Then this coal consumption will be less. It's okay, theoretically fine, but how to integrate it, how to penetrate it into the classical grid is really challenging and see. We cannot turn on when you need them, that's true. So today we need the solar power, but sun is not available in a proper way. Insolation is very, very less. Insolation means sun's radiation is very, very poor today. We cannot turn them off when you don't need them. We do not need the power, we'll put it off. We'll ask sun, now we don't give the radiation, it's not that. So the wind blows at the sun shines at their schedule, not necessarily the schedule we need. That's the biggest disadvantage. It completely depends on nature. Intermittent and not well timed with demand. Intermittent is fine. That is not the issue. Today is available, tomorrow is not available, day after tomorrow is not available. So another 5 days we can go with a good amount of forecasting technique. There is a lot of mathematical probabilistic methods have come up and we can use it, no issue. By using AI and all that, we can go with a good amount of accuracy. But the question is not well timed with the demand. Intermittent, no issue, we can accept it, but not well. There is a small graph I'll explain later on. Supply and demand need to be instantaneously balanced, and this is the biggest issue with the electrical engineering. Possibly you all know. The electrical engineering, we operate nowadays in a deregulation environment in power sector. We know exactly what we mean by deregulation. And deregulation in fact started around 10 or 15 years back in electricity sector. What I mean, deregulation means electricity nowadays considered as a commodity. Even the state utility are thinking that way also. And this concept has come after 2003, this deregulation, open access, open market power. These are the terminology available nowadays in electrical engineering, and hopefully final semester students, if I am not wrong, so that you are having one elective paper on deregulation, because aware that the board study that the issue is there. The reason is very, very simple, and this deregulation concept, I must say, before going into the smart grid, this concept has not come from the electrical engineer, this concept has come from one economist. This communication sector has advanced a lot like anything. If I tell a small fact, it's not a story. Do you know who is the first mobile user in your country? I'm not checking your knowledge, just like that, no. Do you know any idea? If not, let me answer it. Our ex-chief minister, not prime minister and president, our ex-chief minister Jyoti Basu, the first mobile user. I'm not talking in Bengal, in India. And fortunately, I had a scope to see the size of the mobile was this much, and with that mobile, antenna was 3/4 length of that mobile, and imagine the size of the mobile is this nowadays. Within this span, 15-16 years, the communication sector. This is, I'm talking about the hardware of the mobile. If you go to the software part, because any digital technology, there are two things, body and atta, soul, what you call it is software. So both the things are there. Without soul, that's a dead body. So without software, that's a dead body. See, both the things are here. So while we used to talk during that time, I'm talking about 1995, when the price of 1 egg is 25 paisa, I used to go to Durgapur by paying 75 paisa in a minibus. 15 rupees the charge per minute. 15 rupees. And only Jyoti Babu can use their mobile. And incoming charges were there. I don't want to elongate because I have to go some mathematics. But the point is that nowadays, in 2021, if you go and look at the hoarding, because they love looking hoardings, what they write, kothar dam kome geche. You get the thing and using. So what I mean in technological point of view, what amount of advancement has come to this communication sector. 15 rupees for outgoing, 15 rupees for incoming, nowadays not that. Even they offer the SIM, that SIM is absolutely free. I am talking about the digital SIM. But if you go with a vegetable SIM in the winter season, 70 rupees per day, if I am not wrong. So the digital price is going down like anything. Now, with the next question, why? Why the price is going down so drastically, so exponentially? This is one example. I will try to take another example from that side, and third example is our electricity commodity, and another important component of the smart grid. Because of competition. Earlier, only one communication sector, one player was there, name was Hutch, which is finally being converted to Vodafone. Nowadays, Aircell, Idea, that sale, Airtel, here, there are so many players are there. He's telling, I'll give 1 pulse, 1 paisa, well, I'll give 1 pulse, 1 paisa with 1 GB free. Take it with me. You come to me, I'll give much more advantages to you. Huge amount of competition. Price has to go down. In another sector has come, that is the aviation sector. 1991, 92, only the diplomatic people, ministers used to fly they used to go to a distant place by flight ticket. Just after Corona, I had been in Bombay, my fellow passenger was a carpenter. Because of, again the answer, go here, Indigo, there are so many players are available. He is telling, I'll give a cup of water, then he will give cup of water, I'll give a cup of water, and a hot cup of tea from ground, 14 kilometers above the ground, I'll give a cup of tea. Come with me. And the level of competition. Why electricity sector will lag behind as electrical engineers, as academicians? So we started thinking electricity must be considered as a commodity. Once we can consider as a commodity, the question is, can this electricity can be considered as potato and onion? The way you consider potato and onion as a commodity, can you consider it? The answer is big no. And there the technology lies, there this digital technology, communication, Zigbee communication, because this electricity is a kind of a commodity, we cannot store it. Only we can store it. If there is a huge production in 2024, we'll store in a godown, we'll sell in the next year. But electricity, if we generate 1000 megawatt, at that very instant we have to consume 1000 megawatt, otherwise what will happen? The questions of frequency and the biggest issue is the penetration of renewable energy. Because in case of renewable energy, what is the frequency? If total renewable energy, if you get from sun, I mean if it is solar based renewable energy, what is the frequency? Absolutely zero. It's a DC generation. What is the frequency? A synchronous generator, 50 Hz. How to calculate it? We are all talking. We'll integrate renewable energy. But how to correct zero frequency energy with a 50 cycle per second energy? You got my point? So let me start with that frequency, the really very critical number for electrical engineers, electrical teachers, I mean the academicians and all that, a very important issue. Let me illustrate this concept with a small idea like a class. Let me go to the whiteboard. I hope these are all Newton pens are working. It's a small example. I mean, this is the mechanical input. Try to understand. And let me tell you, this inertia concept has come from Newton's first law. Whenever we talk about inertia and flexibility of a power system, they think it is something different. It's not that. First law of Newton, he never used to think that penetration of renewable energy will take help of Newton's first law also. When he discovered, he never thought of these things. Say 150 megawatt is the mechanical input. In terms of megawatt, mechanical input. It is going to the turbine because you have to feed to the turbine if you go for the classical generator. This is the classical generator I am talking, and this is the load side. Again, load we know there are 3 types of load. That we know. Just for explanation's sake I am telling, one is a constant power load. And I will give an example in the constant power load only. One is a constant impedance load. Constant impedance load. Another one is a constant current load. I am not going into details of all kinds of load in huge amount of time. lot of sites are there. So the constant power load. So 150 this is the mechanical power. And here the turbine and synchronous generator are directly coupled. This is rotating. This is rotating means earlier it was static, now it is rotating. Rotating means it is definitely eating, or our engineering language consuming certain amount of mechanical amount of power. So whatever we are receiving in the load side is lesser than that. For simplicity's sake, it is not in practice. Just to make you understand, let us consider this is 100 megawatt. Whatever we are receiving in the receiver side is 100 megawatt in the form of electrical load. This is purely electrical load and this is mechanical load. So it is eating that 50 megawatt. 50 megawatt, where is going? So this turbine is rotating, it has to take some power. Say 50 megawatt power is required for rotation. So this power is coming in the form of what kind of energy? Kinetic energy. But this is not exactly correct answer. Kinetic energy, but again kinetic energy are two types. One kinetic energy in the linear form and another one kinetic energy in the rotational form. Here this kinetic energy I want to mean not half mv square, but the rotational kinetic energy and the linear kinetic energy basically idea is same and the unit is joules. That's the idea same. So it is a rotational kinetic energy. That I also saw how this frequency is the biggest problem. And why when Professor Banerjee asked me why I decided to talk about Rokov in this lecture. My idea basically how to, this Rokov is a very important concern nowadays in every country, in every state. This Rokov, I will talk about Rokov, and the Rokov has come from this side only, you know. This 50 megawatt is definitely is consumed by this. And our classical frequency that you know, Ns, is equal to 120 F by P. Okay? So this P in a synchronous generator is fixed, no issue. 120 to 120 is fixed. So this Ns should be how much to make our country's frequency standard 50 Hz? If we consider P is 4, if we make it to 3000, so for simplicity's sake, let us make, in fact, in practical synchronous generator, it only. So 3000 RPM, so 3000 RPM. Try to understand it. Because before coming to academia, I was in a Durgapur steel plant for 4 years, 9 months, probably sealed down. 5 years industrial experience, not exactly 5. I used to work in a captive power plant in DSP only. So I used to handle this 62.5 megawatt. Still it is there. Now that is not with DSP, rather they are now connected with, amalgamated with NTPC. That is now under NTPC. And if I could have continued with DSP, now NTPC is then employee. So this 50 megawatt is converted, it's not exactly, it's not that out of 150, so much will go for rotational. Just for simplicity's sake, 50 megawatt is going to the rotational part. Okay. So to make 50 Hz, how much energy is required? 1 megawatt. So for 1 Hz, for creating 1 Hz, we need 1 megawatt power, and system will be ideally balanced because we are generating, we are giving 150 as a mechanical input. This is 100 megawatt load. And constant power load, what does it mean? Even if 100 megawatt load, it needs 100 megawatt, not more, not less. And that's the meaning of constant power load. Say induction motor, or most of the industrial induction in Asia, 80%, 80 to 85%, they are what kind of load? Constant power load. So constant power load means if I need 100 megawatt, I need 100, I don't need 101, I don't need 99. That's the basic characteristics philosophy of constant power. So 100 megawatt is generating and constant power load is getting 100 megawatt, constant power load is very happy with this. I need 100, I am getting 100. Suddenly, that's the issue. 2 megawatt has added. Suddenly the power has come. Because of some FDP program in one engineering college, suddenly load has added, lot of lights are going and all that. Suddenly the power has come. And again for simplicity, the electricity consumption of not that 2 megawatt power has come. We will give this 2 megawatt. Now we will give this, because load may come at any time. Before taking anybody's light, before putting this light on, if you have not informed state utility, I am going to put this light on, please increase your generation. No. So suddenly this load has come. So, and once the load has come, this is rigid. You cannot change this one. This is rigid. I can change this one. So this side is rigid. I need load. And you have to give it, because I am paying at the end of the month. Even the state utility land is working in a half deregulated environment, open access environment. This is one issue. And as far as this 150 megawatt, the next answer comes in our mind. Sir, if 102 megawatt is required, we will change your mechanical input. That's a simple answer. But we talk in terms of reality, this is not an easy answer. If you go for 150 to 152, we have to increase the boiler temperature, we have to burn more coal, then burning coal will increase the temperature, then the next step is the boiler pressure, then the steam will come, and that will take certain amount of time. So this side, again we can consider is the rigid part. It is not that, what I mean, we can change to 152, but it will take few seconds, maybe 30 seconds, 1 minute required to go there. But which is that 1 minute is a decade to an electrical engineering, because electrons are flowing in the speed of a light. We cannot give a minute, rather a nanosecond is enough to destroy the whole power system. So this 1 minute, 2 minutes to make up this 152 megawatt is not an easy task. So what will happen? This side is rigid. It's taking time. We cannot allow this much amount of time. This load side will not wait for that. Okay, if you go on increasing, then I will adjust it. It's not that. This side is rigid, so somebody has to be fixed, flexible. So this side has become flexible. This has to. It has to be. Because this is the rotational, it is like a poor fellow, Bachara, what will do? Okay, let me adjust. They are not able to adjust. He is telling that I will take little time. He is telling that I am fixed with 100 to watt, I am not going to compromise. No chance, I am not going to. So this will compromise. So this rotating turbine, what you said, somebody said the rotational kinetic energy, he said that I am having 50 megawatt with me. I will give you 2 megawatt from my side, even though the generation is 150. Are you getting my point? So the additional 2 megawatt is not coming from burning coal, rather it is coming from the rotational kinetic energy. That is not coming from burning coal, and that is not easy task also. So this 2 megawatt is finally coming to this side. It has to be given, because we have already claimed it is a constant power load. We cannot compromise with this. No compromisation, zero compromisation. The moment 2 megawatt will come to this side, now what is the present megawatt for rotational? 48 megawatt. So here, under ideal condition, when the rotational energy, kinetic energy and electrical load, if we club together, if we aggregate together, match to the input energy, the frequency 50 cycle per second I explained. I mean, for 1 hertz, we need 1 megawatt under ideal condition. Now, we are getting for 1 hertz now 48 megawatt. And the concept of inertia, what Sir Isaac Newton told in it first. Inertia means the word has come inner, the Latin phrase, the exact English meaning is boring or laziness. If somebody wants to remain rest, he wants to. If somebody wants in a moving state, wants to moving state. That's a kind of a boring thing. Rather, much more this boring word is much more applicable to our this inertia, turbine inertia, rather than the lazy. Inertia was available in the rotating turbine. Got my point? Because this player is giving kind of flexible role. This is nowadays a lot of people are working in that research domain also. Flexibility of power system, the new type of concept has come last 2 or 3 years. You'll find a lot of papers in the IEEE context. Flexibility of power system in here the coming is the flexibility, not here and not there. Now the question is, if this rotational energy, if there is a problem, either the load increases or load decreases, it could have happened for load decreases also. If suddenly it becomes 100 megawatt instead of 98 megawatt, this 2 megawatt will not go back to the input, so who will absorb this one? It has to be, the additional 2 megawatt has to be absorbed by this. So this is the only flexible part. Now the question comes about a renewable energy. If it is a renewable energy, this side is okay. We are generally, that is fixed. Load is always there. We are the customers, we are the load. What about this side in a solar energy? Who will adjust all these things? Where is the flexibility part? Are you getting my point? Penetrating renewable energy. Who will get this thing? How this rotational kinetic energy is working, imagine, behind the curtain. But in case of renewable energy, and mostly we talk different kinds of renewable energy, I mean this tidal energy, geothermal energy, biomass, natural gas, a lot of forms, this wave energy, whatever it may be, out of all these kinds of energy, solar energy and wind energy is the dominant and prominent one, no doubt about it. Maybe geothermal, but where is geothermal in our country? So we have to depend on renewable means solar and wind. Again, in case of a wind, there is again a difficulty. The thing is this, we get a speed with a very low speed and that again variable. And again, in the case of a solar also, other issues are there, shading effect, and shading effect, maybe the static shadow and the dynamic shadow. Static shadow means there is a tall building is coming nowadays, then the static shadow. Dynamic shadow is very difficult handling nowadays. The people are publishing paper on dynamic shadow. If there are panel, if the cloud passes over that panel, that the shadow falls, and the topology of the shadow is not rectangular or kind of thing. Always the topology of the panel is continuously changing and creating the hot spot on the solar panel. So few IIT, they are talking about how to control the topology of the shadow on the solar panel. Their research topic nowadays. In fact, I have been IIT Bombay because to evaluate that kind of thesis. I enjoyed also how to control the topology of the cloud shading effect. Initially I got a little confused and worried also. I mean, my research thesis of cloud computing, they have used this word cloud. So I thought that cloud computing, but I'm not a man of cloud computing, I'm from electrical engineering, how to evaluate. Then I thought that not that cloud, the real cloud. And that cloud's topology, how it is behaving with the solar panel and all that, that's a very interesting thing. And so those are the issues are there with the solar panel. Apart from that, this part is absent in a renewable energy. How to penetrate it? And there is the biggest issue. And the birth of Durgapur means rate of change of frequency concept has come. And in fact, it is a kind of a, if necessary, I give a small mathematical part if you are interested. It's a kind of a, so far I feel, it's a swing equation of the dynamic behavior of the power system in stability. That's modification of a swing equation, and if possible I'll give it a model. Those nowadays who want to work in this Rocob model, I'll give you a very generic model. You can change the model, go with AI and all that. Nowadays, so the answer is, sir, if this is not available, because rotational part, how do you get this rotational? Why do we care about all these things? What is the necessity? Why should I bother about it? Why should we bother? Because of this constant power load. And the question is, we have to create the fill up the gap virtual inertia. So you are all talking, these polyelectronics people. Anybody, do you have heard this name? Have you heard this virtual inertia? Have you heard virtual inertia? We have to bring virtual inertia. Develina, have you heard virtual? Everyone heard virtual inertia. Virtual inertia is little advanced nowadays. We are all talking about synthetic inertia. It's another terminology come about a year back. Virtual inertia means here the rotational part is there, it can give, okay, I can sacrifice, no issue. Instead of 50, in 48 megawatt I'll rotate. I'll rotate slowly, does not matter much. I'll rotate and I'll give you 2 megawatt. If requirement is less, this fellow will tell I'll rotate faster, no issue. Because if the generation is more, load requirement is less, it has to run fast. The speed will go up, obviously. That is obvious. So he will adjust. I will run fast, but I'll absorb it. I'll absorb this additional 2 megawatt. I will not give a pressure to the mechanical side. I'll absorb. I'll run faster. If your requirement is more, I'll give from my side because this fellow will take more time. I'll adjust. I'll be a bit slow.
So frequency will be changed.
Frequency has to be changed, and that's 40 hertz now. Now at this condition, already changed 40 because per megawatt 1 half, so 48 हो गया, खेला तो खत्म. That's the issue. But there is a limitation that I am coming. And in case of a generation is more and requirement is less, then it will become 52. That's for example sake. But nowadays, because of this 48 and 52, this board explanation won't be act in a real power system. So they go with a grid coding nowadays. Poshoko people, they have done it. So grid coding means you will go within a certain amount of range. That cannot go beyond that. 50.2 in the upper side and 49.5 in the below side. Again there is a region. You can ask, sir, why in the upper side not 50.5, 50.2, very less margin, and in the back side, why 49.5, why not 49.8? There are a lot of reasons from impedance point of view. If you want to know, I can explain in the interaction part, but that's very, very important, and post I decide that grid code. If you follow that grid code, there is the least chance of blackout, otherwise anytime the blackout may appear. So anyway, so this is the fellow can absorb, but in case of solar energy, so you have to create that kind of thing. Turbine is not there inside the solar panel, and that is virtual inertia. So any idea what can be the virtual inertia?
नहीं, solar system better will.
Solar, because we have to. I have already explained. Coal will be finished after 50 years, 60 years. Sun will be there for another 10 to the 3 billion years. So solar system is a system only to us.
So battery storage will act like that.
That's a good idea. Only battery storage will not help us. But battery storage is a beautiful solution, and in fact, in virtual inertia, battery storage is one of the important components of this virtual inertia. And another important component is converter-inverter-based power electronic devices. For that again the question comes, the moment we add power electronic devices, we invite a lot of pollutants. What is power electronic devices? Whether it is inverter or converter, it's basically switching devices. Any kind of switching in electricity world, it creates kind of pollution, it creates kind of harmonics, it distorts the wave. But for that again, they will go with a lot of filtering arrangements, active filter, passive filter, hybrid filter. So many filters are available added. So active filter, passive filter, hybrid filter, inverter, converter, and good amount of storage, if they can club together, is nothing but virtual storage, virtual inertia. So virtual inertia is basically a battery storage with power electronics devices with fast frequency response device. Because what this fellow is doing, It is trying to adjust the frequency. So we are only bothered about the frequency. If we could have got 50 Hz from solar energy, we are not thinking about flexibility and then all that and all that. The sun cannot give 50 cycles per second. But we know how to create it by other devices. So you'll get DC generation, and because frequency is a very, very critical number in electrical engineering, we have to create this with a fast frequency sensing or fast frequency response devices. So what you need is a good storage, good power electronics devices, maybe converter, maybe inverter or combination of both, and fast frequency response device. If we can club together properly, that's nothing but the virtual inertia. Say the power is required. Let me tell in a very layman's language, in a simple language, if 2 megawatt is required, this fellow is supplying 2 megawatt because he told that I am rotating, I will give you 2 megawatt and for the timing I will rotate slowly. The moment it will 50 Hz, again I will come back to my own speed, no issue. I will sacrifice it. But if I am having some kind of storage device and if we can get 2 megawatt on instantaneous basis, for that what kind of circuitry is required? Some kind of frequency detector circuit should be there which will detect the frequency. That will come in the form of a feedback, and that feedback will then now the ideal frequency is 50 Hz, now it has become 48. So immediately add energy to make it 50. So that energy will immediately, if it will need energy, then it will come from directly energy cannot tap. Some converter will be there because that have to bring to the 50 Hz. If you want to mix with the classical grid, or with the solar energy, you have to convert to other kind of this inverter based energy, and then you have to feed it. And the problem will be resolved. Whenever all these things come nowadays it is not a fashionable. I tell you, mostly except one or two, mostly junior than me, much more junior than me, except Topunda and all that, if I am not wrong. So the thing is that another thing has come with this virtual inertia, that is known as synthetic inertia, and people have started working with the synthetic inertia. Synthetic inertia is nothing. If this thing works independently, again there is a question of time lag and all that, and that will create the problem. So the thing is that this AI and ML now is not a catchy word, not a buzzword, that is the order of the day. We have to adopt it as early as possible, otherwise you will lag behind. So if we can add artificial intelligence and machine learning, artificial intelligence, so far I understand as an old man, old teacher, it's basically gillion and gillion, trillion and trillion data driven kind of concept. So if we can, and it takes the past. So that kind of artificial intelligence and machine learning, if we can able to integrate with this virtual inertia, the things become synthetic inertia. And synthetic inertia, synthetic, again plastic kind of thing is there. Synthetic inertia nowadays, Australia and USA people are following synthetic inertia. It's not a new concept, it's not that way. Maybe for last 6 or 8 months, they are using this because AI has come up like anything. AI did not come up in synthetic inertia. It has come in Amazon, Flipkart, in my mobile, in this pen purchase, you are also applying AI, knowingly or unknowingly. When you book in Amazon, Flipkart, give Damtakanti toothpaste, we are applying AI in indirect way. AI in everywhere, right from food packaging to convert virtual image to virtual inertia to synthetic inertia also. So they have applied this AI and ML in a huge amount to this virtual inertia convert to synthetic. The reason is this, because in USA, the western part of this, we send the money through Google Pay, but where are the Google Pay offices? Do you have any idea? Mostly the western part of USA, mainly in Seattle and in Colorado State. And the Seattle, the Microsoft having 25 buildings of 25 storied houses. That's the beauty. In Seattle, if you have a scope to go 25. Say, for some reasons or other, power is not there.
Can you explain in that portion Actually, virtual inertia, so far I have
Yes,
conceived
yes,
from
yes.
the lecture, that is a hardware basis.
Virtual inertia is hardware. It is a model
It is
that
hardware.
whatever I have said, that is everything hardware. With
But
that,
how it can be plastic inertia, hardware?
I'm telling you, plastic means
A concept.
that's
Hard to
this
concept.
let me explain it. This I told rigid, this is flexible. Why this you have to understand. That's why this turbine coupled with alternator has become flexible. Why it is behaving like elastic fashion? Why? Because this rotational energy can be, let me explain in a much more simpler manner. Say rickshaw puller is pulling a rickshaw with one passenger and he applying certain amount of pedal force. Suddenly one passenger upon the may sir come. If the rickshaw puller applies the same pedal force, rickshaw speed has to go down. That's the obvious, that's the natural phenomenon. And who will adjust it? So if I want to adjust that one, rickshaw puller has to give more pedal force. So only adjustment is the turbine. So that is the synthetic zone in the reality. That is the synthetic zone. Or if the same pedal force is there in the rickshaw, if the passenger gets down suddenly, obviously the rickshaw will move in a bit faster manner.
So that is input, no?
Huh?
That is input.
The pedal force is the input, that's the mechanical power. That we are keeping constant, we cannot change it. Because a rickshaw puller cannot change its pedal force suddenly. Suddenly it's stuck, it's not that. It will take some time. And especially in electrical engineering, nanosecond is a matter. I'm not talking about minute and matter and second, it's not that. The nanosecond is a constant. Anything may happen. Okay. If you know the issue of 31st and 30th July of 2011, maybe Professor Banerjee can remember the year, but I can still remember the month. So that's the issue, that's the flexibility zone and they can take it. Keeping pedal force fixed. That's why I took this example. So here it can similarly, in the power electronic side, that is completely hardware with the first responding frequency device. So that is the issue. So that is completely hardware. But on the basis of hardware, every hardware again takes some time to decide it. So what we are adding artificial intelligence and machine learning, because as AI is basically the data-driven based mostly and past history based, it is easier to take the decision. Basically, it is time saving. So that they are doing. That the USA people are doing, the western part of USA, they are very clever people. In Texas, they have never gone with the renewable. They based on classical side only. They are very a fellow.
They are not going renewable?
No, they are not going renewable fully because they are having a huge amount of coal. Only with the help of Dadagiri, they are taking coals from different countries where it is available. When all the countries will be exhausted, they will start picking off. They will digging up. So that they are different countries. Their attitude is different. So forget about them. Let us come to technology side. So this is the thing. If you add AI and ML, the whole thing will be much more faster. I mean, you are adding some kind of software with that, and the system, and they define it as a terminology, is a synthetic inertia. So they are now talking about synthetic inertia. But synthetic inertia, the way I work, it's not easy task. A lot of parameters are involved that you are controlling in every instant with the help of AI and ML with a close observation. Funda of this inertia in a classical generator, synchronous generator. So let me with a small derivation from the scratch level, from very, very fundamental level. And from there we'll get how this is rotational inertia, we call it as this. From there I will try to develop a small model for renewable energy, in fact. And that model, nowadays in a lot of literature, that models are available in a different form. And those models can help you a lot to write a paper nowadays on synthetic inertia or virtual inertia. So let me start with a scratch. And because in mathematics, I will take the help of this paper. Very simple, in fact, everything. But
from maybe 9, 10 standard mathematics. No, that we call as an arc, and this angle is theta. This is, say, I have defined as L, and this is the radius. Then what is the length of the arc of a circle? This, or what is the length of this? I have started from very, very scratch level. And I am explaining about that inertia. Why do we call this rotational inertia of the turbine as an inertia? That I am trying to explain from very basic math. So L is nothing but smaller into theta, that we know. As simple as that. Then what is rotational velocity from that rotation? That's why I have drawn a circle. Instead of linear, because the turbine is rotating in a cyclic fashion, instead of going with the linear, directly I have come to this. Now what is this rotational velocity? If we claim it a small v, rotational velocity, so how much path is covering divided by t? The path is nothing but capital R, capital L, capital L, that I have already expressed in terms of arc, is nothing but r theta. So r theta upon time is nothing but the angular velocity. This is okay? When the turbine is rotating, the velocity, angular velocity is this. Now in terms of kinetic energy, if it is a linear system, we know as half mv square. We are not interested. Turbine is rotating in a cyclic fashion. So kinetic energy in rotating motion, if we talk in terms of this is nothing but half m, how the thing is coming. What about v now? V is nothing but r theta upon t. R theta upon t, then this whole square is equal to half m. What about r by this t, this omega? What do you mean by this m? This r theta upon t, r theta by t, that we can claim it. In fact, I have simplified here. This is theta upon t is omega r. That we can write it omega r whole square. That we can write, isn't it? R will remain as r, that is the radius that we cannot change. Theta upon t is nothing but this omega. Sure, this is omega r square. M is the mass and omega, yes, h. Half m omega square into r square is nothing but half m r square into omega square. What is m r square?
Moment of inertia.
This is moment of inertia, which generally designate by the capital letter J. This is moment of inertia. In case of a linear motion, this is mass. This is angular velocity. This is linear velocity. In case of linear motion, this is mass. In case of rotational motion, mass is already there. Instead of that, r square is multiplied there. That is moment of inertia is nothing but half j omega square, and j is the moment of inertia. I think this is clear to you. Now let us define for any kind of system. Why we are defining this for writing a paper? Because in our country, frequency is 50 Hz. European countries, they follow 50 Hz. But if you go to Japan and USA, their frequency is entirely different, 60 Hz. So instead of considering 50 and 60, rather we consider as a natural frequency or normal frequency irrespective of their country. So instead of writing omega is that f is equal to 50 or 60, let us claim as omega n. So let us claim that way. So the normal frequency Fn, if we consider it, this is the normal frequency, whether you can see the normal frequency, then omega will be as omega n is equal to twice pi Fm. Hopefully it is clear to you. Irrespective of the country, even if India, the value of n will be 50 and accordingly. If it is USA, omega 60, then accordingly it will be changed. So instead of claiming 50 and 60, I am making it much more general. Omega n, instead of omega 50, we are making it 2 pi Fn. Fn is the normal frequency or nominal frequency of any system.
Depending on the country, we define it, this FM. Now, this moment of inertia, if you can remember the swing equation in a stability chapter of power system, maybe in 6th or 7th semester, we generally teach the students, UG level students. This moment of inertia is not the good index of calculating the rotational energy of the synchronous generator. Then what we do? Because rotational energy we are not exactly getting from turbine. We might get from the turbine, we might get from the load side. So a lot of rotating devices are there in that side, also load side. Even I talked about that virtual inertia and synthetic inertia. Synchronous condenser is a very good inertial device. Sometimes you use it also. Synchronous condenser, not to boost up the voltage level by injecting. That's a very good inertia compensation device. So, instead of this J, where is that road J? This J, we define by something else in a power system stability. If you can remember, that is nothing but capital H. Can you remember? We never express by J, rather capital H. And how do you get H from capital J? Simply divided by apparent power Sn. Because the moment we divide by the apparent power, whether it comes from the turbine, or whether it comes from the induction motor, whether it comes from condenser, it does not matter much. It is true for any rotating device, and it does not matter on the size of the rotating device also. It does not matter on the rotational speed of this. So generally, instead of defining capital J, we made it little generic and defined by capital H. So H finally will come after simplification half of J omega square by Sn. I mean, if this we divide by the apparent power Sn, the whole things become H. And this we have already defined as kinetic energy divided by Sn. So kinetic energy divided by Sn will give you a kind of indication. This H is again a kind of inertia constant, but this inertia constant does not depend on the size of the machine, does not depend whether it is coming from motor or generator or from synchronous condenser. That's the beauty of converting from J to H. So all that expression in power system stability you will find it instead of capital J. So just you divide by apparent power, it's easy to convert H. So we are trying to convert everything in H. So if we get from one turbine or one rotating machine, we are able to calculate H. But when we talk about a network, power network, there are multiple H are available, isn't it? You got my point. Maybe there are 100 alternators are there. So 100 H we are getting from the 100 turbines. There are 10,000 induction motors are there, just for example's sake. So 10,000 H we are getting from that side. Maybe 250 synchronous condensers are there. So we have to develop an equation, to develop the model, kinetic, not kinetic energy, rather we have to get the rotational kinetic energy of the system, not the individual motor and individual turbine. So instead of KE, rather let us define as KE system. So how to define this KE system mathematically? KE it will all come from the generator sides. Let us consider the n number of generators. So we have to use summation sign, capital sigma. I is equal to 1 to, it says there are n number of generators, then n number of turbines. This is their E, this Zi plus summation I is equal to 1 Ke, I mean maybe motor or maybe load side, load area. Is it okay or not, this expression? From I means 1 to n, from all alternator, all the thermal based alternators are connected to the turbines. So from each turbine you are getting certain amount of kinetic energy, summation of all these. Plus there are say 10,000 induction motor if you consider the load. So individual load we are getting kinetic energy, some rotating energy available. And the interesting thing is, the beauty is that energy is free. Why it is free? Huh? KE load I from 1 to 8. There are number of loads are there. So there are 10,000 induction motors, so 10,000 free energy will get, free, manage everything. Buy 2, get 1 free. So run the boiler, get inertia free. That's the concept. So that's the concept. So inertia is free to us. So suddenly when 2 megawatt, I explained in my before taking tea break, that when 2 megawatt suddenly came into the system, where from that 2 megawatt gone? He slowed down. He slowed down, but he has not taken any amount of coal from that side. So free. So the consumers enjoying free, 2 megawatt, free, everything is free nowadays. So this inertia is free. So if so many rotating things are there, this kinetic energy system, rotational energy, which is absolutely free to the total power network, is a summation of this. Hope this is clear to you. This is nothing but summation of all individual kinetic energy from the generation end and from the load end. Is it okay? This is okay? Now, using this kinetic energy system which is freely available in a power network to a swing equation, to a dynamic equation of the stability, because what exactly we want to do, if there is a small disturbance, in fact, in renewable energy penetration, I should not say this word disturbance, rather is a kind of a contingency. Suddenly if the power comes or goes off, or if there is a small kind of fall in an inter-transitional power sector, better defined in terms of contingency rather than fall, rather than disturbance, and possibly all the equations so far I understood, everything they have defined on the basis of n-1 contingency. Now let me ask you, what do you mean by contingency and n-1 contingency? Everything is defined on the basis of n-1 contingency. Contingency means a kind of a fault. System is not operating under normal operating conditions. N-1 contingency means there is a certain kind of a big disturbance into the system, in a system, but the consumers, they do not understand that there is a system. System is running smoothly. Maybe the economical part of the power system gets hampered a little bit, but technically speaking, there is no problem in the system, either in the frequency level or in the generation level. That is known as n-1 contingency. So, system has not gone out of gear, system is not perfectly smooth, and under that condition, if we are able to manage this kinetic energy freely, because we are penetrating renewable energy and the equations of the stability will be, then will be a different kind of equation. D del F, this is the biggest issue nowadays, dt, this del F is change of frequency. Where from this change of frequency is coming? Because of variation of generation and load. Generation load perfectly matched, this del F is 0. If generation and demand does not perfectly match, we are getting del F. But because of penetration of renewable energy, well, at least bother about del F, we have to go much more deeper. We have to take the derivative of del F. How the frequency is changing, if you plot a curve, that is called the characterizations of del F nowadays. And in fact, in our country, in every state, every city, they are going with the different characterizations of Rookoff profile. Here LDC people are doing means the computer do it, so they are going with the different kind of characterizations of the Rookoff. So this del F, how they are changing at every point, del F is nothing but change of frequency, and that change of frequency with time domain, I mean, is a kind of a slope we can define. Any kind of derivative with respect to anything is a slope, m. The physical significance of derivative is like that. If we can able to calculate, then under renewable penetration, this will be, Fn is the normal frequency, upon 2 KE system, this has come from this only. And probably the very familiar equation that we have seen in a swing equation, but in a little different way I have written. What is that swing equation under normal conditions? D square delta dt square is equal to PA, the accelerating power. But here, not that one. Rather, we have defined in terms of change of frequency with respect to a time domain, and this we define as Rokov. Have you ever heard the term Rokov? Rokov is the new issue nowadays. We are least bothered about the change of frequency, least bothered. The way we are least bothered about this camera phone, where the video and message we cannot transfer. Only the old people like my mom, they use this. We are bothered about iPhone and all that, or sophisticated, lot of thousands and thousands features will be available. We are ready to pay the money and we want to enjoy the features. Similarly, Rokov is the biggest issue nowadays. We want to go into much more deeper to the frequency deviation to penetrate the renewable energy. We want to add one more feature, the change of this frequency in Rokov. So this we can define as Rokov, and this is the kinetic system available. This is the nominal or normal frequency, and Pm minus P is the accelerating power. Say, let us go with this case study. Say mechanical power is exactly equal to the electrical power. Let us go with this case study. For simplicity's sake, what will happen? What is the value of del F? 0. What is the first order derivative of 0? 0. No change. Mathematically I am telling you, no change. If you go with math, forget power system. But Pm minus P, let us consider is an accelerating power, and this P is greater than 0. Say consider Pm minus P is equal to Pa, and say Pa is greater than 0. Pa greater than 0 means load demand is less compared to the mechanical generation. So obviously del F will be there, has to be there, del F will be there. Del F is already there under n-1 contingency. Try to understand. Del F means kind of disturbance is there. That's why the frequency variance is there. Under an ideal condition, it should be only a 50 Hz. As because there is a disturbance, demand is less, generation is more, that is not a good condition. Generation is less, demand is more, that is not a good condition. That we have seen in our family life also. Demand is more, supply is less, always calling. Always it has to be some kind of contingency will be there. Our system is not a different story, same story. If P greater than 0, then what will happen? So kind of disturbance is there, contingency is there. If we consider it as n-1 contingency, so n-1 contingency, Pa greater than 0, and at the same time, we have understood that this coal energy is gradually depleting in nature. Our mother environment is already owned. We do not want to hurt her. We have to take the renewable energy and have to put into grid. So, putting renewable energy into the grid is another contingency. There is a change of frequency delay because of this variation, and whatever we are adding to the system, that does not have any frequency at all. Zero frequency. So it is another dangerous thing. If you can go with a little corrections of frequency device, that is good. He can correct it. But we are adding an energy where is the zero frequency energy we are adding with this. So another kind of disturbance we are putting into the system. You have to understand it. Just penetration is not a child's play. It is a Herculean task in fact. So this del F dt is this n-1 contingency is appealing or rather inviting another kind of contingency. We can claim it as n-2 contingency by adding renewable energy, and it is deteriorating further this Rokov. And let me tell you, if I not again can remember correctly, not wrong, maybe 7 or 8 months back, Sandeep was there probably possibly, or maybe 1 year back during this corona period, that people, his name is, my name is almost same. My is Chandan Kumar Chanda, Chanda is not there, Chandan Kumar. And anything ends with Kumar means he is from here. Abhishek Kumar, Chanda is from here. He is basically an employee of here LDC. He told that, sir, evening time, the present penetration of renewable energy into our classical grid in India is only in the tune of 10 to 11%. Lot of things comes in the literature, all of it's absolutely useless. Only 11%, I'm saying in front of a camera, which we transfer to MOE, so only 11%, and this 11% penetration, that Chandan Kumar is feeling in every meeting, have to leave the job. Very difficult to control the load curve and frequency, not about this delay, about the runoff. Also, it is very, very difficult to control, and every time boss scores like anything, bark like anything, rather precisely you use this word, and every time I feel, sir, can you manage that teaching job for me? I am unhappy with this. Very difficult with 11% penetration of this renewable energy, as we are talking about. He told that, sir, if it goes 15%, 16%, will be no here. And that too with 1-1 contingency situation in eastern part of India. That's the scenario maybe 1 year back is very difficult in evening time because of this law. These are all practical issues. Whatever, sir, you teach in the blackboard and whiteboard, that's easy thing. But in evening time, we face the music, sir. So that's the thing. So this is the issue. Nowadays, in fact, they face this record issue. How to mitigate this issue? I said this virtual inertia, synthetic inertia, synchronous condenser, that's a very good solution, no doubt. Another solution is here inside the system, if you can able to provide a little bit damping. If we provide a little bit of damping, then what happens? Frequency variations mean in any physical system is a kind of oscillations we can think. And if we can add additional damping into the system, especially if we add the renewable energy and we can add certain amount of damping into the system in a very judicial manner, not more, not less, then system might behave nicely. So we are adding little damping system to this, and let us modify these equations again. So this rho will be equal to Fn 2k E system, and this Pm minus Pe, let us consider as del P, change of power in fact. If Pm is greater than P or P is either it may be positive del P or negative, maybe better to write plus minus del P depending on the behavior of Pm and Pp. This is this recording change. Okay, now we are adding these things. Explain you, this is del P minus D for damping, P for load, and delay. If we multiply change of frequency with the load with the damping factor, there you can design it and subtract from this power variation, then we can manage the ROCO up to certain. ROCO means change of frequency with a time domain. Rate of change of frequency can be reduced if you can minus something from this. Earlier this expression was not there. If you put something positive in this side, then obviously this will go down. So a kind of damping arrangement in physical way, if we can provide with this modified swing equation of Rokov, we can able to adjust the rate of change of frequency variation in time domain. Are you getting my point? So this damping phenomena have to be adjusted whenever we will put the renewable energy into the system. It's not that where solar panel is there, some generation will connect it. It is not that. Before connection, you have to think a lot of things. Otherwise, indirectly or directly, knowing or unknowingly, we are inviting a lot of contingency with the system. So that I can explain you in a very simple way. Mathematics does not help you. Let me explain you with a small diagram. Say, what exactly ROCO means? Say this is a water bucket. This is generation. Generation means some input is coming. This is the output is going out. So let us consider as load, and this level, this is the water level. Say this is delay, rather the frequency. This water level I want to mean the whole mathematics I try to convert in the form of some diagram. This water level is del F or frequency. So going out is a load and the going in is a generation, this water. So this del F, if this is the size, then if generation is more and load is less, then what will happen? This will rise. That's true. Some change will be there, right? In other way around, if you talk in reverse way, if this is more, then it will drop. Now let me change this figure. Instead of this diagram, this is water level will remain same. I have changed the size of this container, generation and output is same, then how this del F will behave? How this del F will behave if I change the size of the container? If generation is more, load is this, now del F will of course go right, but in a very fast manner, because the container size will become less. Are you getting it? Container size less means the system without damper. Are you getting my point? If you add damping means you are virtually increasing the size of that system such that the rate of fall or rate of rise will be less. Hopefully you got my point from this diagram. And that's the thing happening inside it. This Durgapur. So if I go with a small generic model, there are a lot of models available in different literature. I mean in good IIEST journal, you'll get it. Let me, as because the FDP kind, I am going with a general model. You can modify the model and you can write a paper with this. So let me this model you can develop in your own, but whatever the data and inputs are available, whatever the things I explained you, let us consider these are all raw data or the perception layer. In terms of IoT, what we say, we will collect the data, all these data will be formed in the raw form, that is called perception layer. That perception layer will go through the sensor, that is called the middle layer. That layer will again go to the another layer, that is called the network layer, where a lot of protocols will be there. And the network protocol layer, the cloud computing layer, another layer, there they will be processed and will go to the output. Here the model is based on that perception layer, and then the advanced sensing layer, then the network layer, then it will go to the cloud computing layer, and then final output. So let me draw this bottom-top approach in a model form. I think this model might help you. I'm not sure if you what in this domain might help you. This is yes, and this is G. These arrows are very, very important. I'm trying to develop, I'll explain this diagram in fact. This is plus, this is plus, this is minus, this is P count, power count, changing. And then this is coming to this side. This is plus, this is plus, this is plus, okay. And from damper side, this is P load, this is load damping. Load damping is required, otherwise you cannot change the size of the container. And then from this del P is coming, change of power. This del P is going by the model 1/2KE system. Then it is the change of frequency del F. Then del F is going back to this side. I am first drawing and then I will explain it. Then this and then this. This is contingency, P count contingency. Plus, plus, minus, this is plus, this will go to this side, damping will be also go to this direction, that's right. This is P load, this is load damping, Upriya. This is the most generic modeling of virtual inertia when you put renewable energy into the classical grid. A very, very generic and very fundamental kind of modeling. This PS I want to be in the generation, this I want to be in the load kind of thing, and this is the damper. This is added to the system. This I tried to explain with the help of a control system. From there the del P has come. I mean the change of power. Del P means this load power is going. If it is a plus or minus, accordingly it will come to this. This will go to this inertia system, and this inertia system will finally decide the del F, and this finally del F will go in input to this base and correct it. And this del F is not going to the generation, in fact, it's going to the lead. Yeah, it may be, this del P may be negative. That depends. Yeah? Damping part cannot be negative. Damping part generally do not provide. Negative damping will be then it's very, very difficult. You always go with the positive damping.
Minus this term.
That will be positive. Because the value of damping is always lesser than this. Always. It is positive. But a damping can, then the system will not stand at
I
all.
understand that it will subtract from that del P GM.
The del P means already this change of part, then the system has come and del has come from this side. And this is already subtracted. You want to mean the mathematical model, no?
So that,
Yeah.
that part.
It has gone to this side, it is the
So it will be
becomes.
negative, that plus the lower one. Yes, sir.
No, damping point, this should be minus. That's right. This should be minus, absolutely. This is plus, no doubt behind it, but this should be minus. Because it should be added in a negative side. Then only it will be, that the size of the container will be more in a physical manner. You got it? That is the simple model of renewable energy penetration into the classical grid for developing the artificial or virtual inertia. Just like number 860, okay. I can just I can go through. These are the challenges. Now let me show you. If the supply and demand is perfectly balanced with 50, you see this, the right hand side curve, you see the red one is basically load demand. And PV generation, that you know the solar PV curve it is, how to match it. If this red is matched with this sky color one, there is an ideal one, 50 hours. But we will match it. We have to match, the load rate is in our hand, we have a certain amount common. But the PV curve we cannot change it. We cannot get the peak PV power in the evening time. Only we will get at 12 o'clock. So we cannot change it. The sky color curve is fixed already. That's gifted by nature. So if we can be able to adjust, now we see the adjustment. If you have a look, you will see from 0 to around 9:30 or before 10, the red curve is on the top of that. I mean there is no solar generation. Load is there, but the gap is very, very small. I want to mean not the curve, the gap between these things. That can be adjusted. Otherwise, this delay will be huge issue. And if you go from say 9 to say 8 o'clock, something like that, then you see the load curve is far below the peak of this PV. There is a huge amount of gap compared to this. So what we can do, if this gap and the gap after 20 hours, I mean 8 p.m., both the gaps, if we can take judiciously and able to match with the virtual inertia and able to match with that gap, very difficult. I can show in this presentation file, but in reality it is very, very difficult. If we can able to match, ideally it will be 50 hours. Are you getting my point? That is the issue. But it is challenging. These are all challenging issues. So I promise that I will go with a little recommendations and prescriptions for that how to do. So let me go at least up to that slide. Intermediate well not defined, each supply very needed, these are already explained. This is the thing I tried to explain for last 1.5 hours. The first one you see, generator, generator dominated power system, I mean the synchronous generator, and the right hand side is basically inverter dominated generator, I mean basically solar generation converter based, that is inverter or converter based power system. Here in the right hand side frequency 0 and the left hand side in ideal condition frequency 50 Hz. Challenges of renewable energy system frequency that I already explained and telling again and again. Frequency is a very, very critical number in the system. It tells us how much the system is synchronized and the status of the supply and all that. Integration of wind and solar power plants into weak grid is another issue I have already explained into the weak grid, and short circuit ratio of a grid is very, very vital issue that I already explained. And another important point, I have not mentioned earlier the common coupling point. CCP is very, very important now, because nowadays you are all talking about electrical vehicle, very easy to share, very good to hear also, everything is okay, perfect. But electrical vehicle, the moment you will put into the grid, do you know what will happen? Because you have to put the electrical vehicle in the distribution sector, not in the transmission sector. You cannot connect EV in 132 kV transmission line. You have to connect in the distribution sector. In distribution sector, what are there in the distribution domain? What are there? Distribution kind of transformer. In a distribution transformer, there are two windings. If we consider for a single phase domain, single phase kind of distribution, then what are primary and secondary? In distribution transformer, if we put renewable energy, how the power will flow? Now the power will flow in both the direction. It's going from primary to secondary side, secondary to primary side. Distribution transformer till today is designed for power flow in unidirectional manner from primary to secondary, not from secondary to primary. Can you see any transformer is designed where power can flow from both the sides? It is not feasible because of questions of these iron losses and all that. So if we connect again distribution transformer, every 1 month you have to change it. That will be deteriorated because of heat generation. So again, another important point has come off in the power system, especially in the distribution sector. We have to find one common coupling point where you have to connect the renewable energy. Just like that renewable energy available electricity. It is not a plug and play game. Plug is there, just inserted it, it's not that. It's not a plug and play game at all. There is huge technology and mathematics involved. You have to find an optimal common coupling point where you have to throw the renewable energy. At the same time, you have to think about the distribution transformer if you go with EV charging. Because the solar generation is best for application. Where is the best application of the solar energy? Or battery charging. Because this is a DC energy. We cannot directly use for this induction motor, solar energy. Then you have to go with a converting device, match with the frequency and all that, keep the voltage and power fixed. So a lot of issues will come. And harmonics and all. The moment you will put power electronics, harmonics will come, that you have to mitigate. So the question is, we go for battery charging, mainly the solar energy. And why we go for battery charging? Because of these electrical vehicles and all that. Because sometimes electrical vehicle itself behaves as a generator. When they are ideal mode, they give the generations. So those are the important issues are there in the renewable energy penetration, and we have to find some optimal common coupling point that CP. That's very, very important, where SCR should be tremendously high. If SCR is low, system is less stable, less flexible. If SCR is high, system is more stable, more flexible. So you have to find a common coupling point in the power network where SCR is relatively good, fairly good. And that again not easy task. Already Professor, our geographical area is very, very vast. We have a big 5 grids. All the grids is not that only alternator. Transmission, distribution, generation, we club together, then it makes a grid. And in such a geographical area, getting common coupling point is another challenging task of renewable energy. And that in fact is government facing problem. Challenges of renewable energy, if the system's strength is very, very high system strength, and if there is a fault, you see the voltage fluctuation, very smooth almost, and we can able to cope up. But the low system strength for SCR is very, very low, and see the voltage wave and the fluctuations. Who will handle it? How much harmonics has come into the system? Who will estimate that harmonic? How to mitigate and eliminate the harmonics from the system? How much third harmonics will allow into the system? The third harmonic is the most dangerous harmonics in the system. Even fifth is dangerous, but third is much more dangerous. How to eliminate those issues? So challenges of these are overheating, if harmonics are there, overheating, voltage stresses, poor power factor, possibility of system resonance. Then let me finish with the least possible solution, some kind of recommendations.
That is the thing. If there is a day, there is a night. If there is a night, there is a day. If there are problems, there is a solution. So let us go in the complementary part. We talked about all challenges and issues and negative issues of penetration. So solutions are here. The first solution is not feasible. I tried to attack the inertia part. IoT now with smart grid is very, very good. It should not be smart grid. Only smart grid is not enough. It should be IT based and IoT based smart grid. That's a very good solution for this renewable energy penetration. Choosing anti-coincident sites and larger area grid interconnections. In fact, possibly you know or do not know, I don't know, you young generation keep a lot of information rather than me, that Sahara Desert have started producing generation and it is able to cover 1/25th of their land. We will get a huge amount of anti-coincident sites because not India, universally, they are trying to increase the anti-coincident sites to mitigate this issue. And they have attacked for Sahara where the solar energy is abundantly available and easily accessible, is not easily accessible, very tough. How to install the transmission line in the Sahara Desert, another issue, they'll think it. But they are planning, at least if they can occupy 1/25th of the Sahara Desert, they are planning for their doing. So they can increase the anti-coincident side, they can balance these frequency violations up to some. That's a kind of a, this wider balancing area. Then balanced storage system, already I have said this battery, pumped hydro. Storage is a very good virtual inertia, they can provide, if we need the energy, if store can give, it's better, very good. Then balance with the dispatchable generation plant, natural gas combined cycle, we cannot throw it out. We have to keep side by side that one, this oil waste or petrol waste or natural gas waste or coal waste generation too. For better frequency mechanism or better frequency management. Demand response have not covered. Few slides said that demand response or demand side management is a very important issue nowadays. If you can shift the load low, somebody said that in USA, how they do it? They do it because they are having a lot of ultra modern gadgets, and they strictly religiously follow all these things, And there are having kind of regulatory mechanisms also. In our country, if they want to adopt, if you take the power, in fact, CS is going to adopt this one, from 12 o'clock to 4 o'clock, they are going to charge 2 or 3 times of the normal tariff. If the normal unit charge is 10 rupees, they are going to claim in some time it will be 30 rupees, 40 rupees. So, during 12 o'clock or 1 o'clock, if you want to go for washing machine and all that, you have to pay 40 rupees per unit. You please, when you go for sleep, that time put the washing machine, go for sleep, in the morning you take the help of a son and dry up. So they are trying to shift the load when the peak demand is there, and if that way, they can shift the load from the peak demand time to the lean demand time, the suppliers are having a lot of advantages. They need not go for capital investment, they need not go for so much amount of installment. I mean, the install capacity will be less, but they follow it very religiously in their country. Say, do it because regulatory mechanism is there. They'll catch hold of if they use that. And in our country, if they ask, you use the washing machine from in evening 10 o'clock, the first issue will come from the who is CSV? I know what we are doing. So nobody is bothered about it. So the question is the regulatory mechanism and discipline mindset. A lot of issues are there in the demand side management. And curtailment control charging of EV, that is very, very important. EV will play very important vital role in next few years. So curtailment control charging is very, very required for EV. Otherwise, in every certain interval, you have to change the distribution transformer. And harmonic distortion is an issue, and that we can mitigate by a lot of filters issue. So all this installation of SBC, STATCOM, reduction in the registered plant capacity, frequency, that way you can all manage the frequency. Possible solution, flexibility I already told in the turbine side. Ramps, turn down and shorter peaks can help. Shorter peaks is one of the management aspect of the demand side management. If you can reduce the peak, it helps a lot. But it needs it needs a mindset and as well as a lot of other technical issues are there. And there I am ending my session.
And other part is the smart grid. Smart grid possibly know, and that will take another 2.5 hours. I'm not going into details of this. But let me tell you in a brief, smart grid and IoT smart grid, or what should I say? This AI and email-based smart grid nowadays takes a lot of mitigating on the information. But high
Response capacity, IoT
Yeah.
is required for market, no?
IoT?
Due to high response, IoT or IT-based market is useful.
IoT is everywhere. IoT plays a very important role in the this renewable energy integration to make the grid more greener as well as to make the response more faster. Only IoT can do it. Human intervention is not feasible. Time consuming.
In the cartel grid control also IoT.
Everything is done IoT. Whatever you should order to this, that's Uber, that's IoT based AIEST. Everywhere, where you not find the IoT? IoT is not what is the full form of IoT? Information of technology, they used to say, now it is said information of things, everything. Everywhere, even this maybe the machine they produce is made up of the IoT machines. They produce more this kind of jackets. Everywhere this IoT is there. Even the small toy maybe IoT is involved. IoT is everywhere. So this is all about from my side. I try to conclude within my this defined time period by 4:30. Maybe I have exceeded another 5 or 10 minutes. Very difficult to complete such a large topic. So I told you in the beginning, I'm happy to answer. If any queries here, the way anything if you want to
The
know.
first time you were telling us some free, but nothing can be free. The
Nothing
first
can
time-
be free means
At the
that
first time
if
beginning,
you
you
look this,
buy one get one free.
no, that is there in every word there is a magic, no. Free, this is
Where
what
actually
is
it is
coming.
coming?
Free means if you remove P or R, then it will become P. If you look this word very closely and very meticulously, in the word free, if you eliminate R, then it is a free. So that free rotational energy you are getting, but before that, you are burning the coal. So, somewhere you are burning something, then only you are getting, but that inertia will automatically come, by default it will come.
By default it is coming, but
By default,
it will not
until
be.
it is rotating, it will rotate, how 50 Hz will get it, we have to get it. So, by default, as a byproduct, sometimes we electrical engineering people say, this inertia, as a byproduct, it is free.
Yeah.
Now it is clear to you?
Uh,
This free as a byproduct. Now we are happy with this, I think. Any questions? If not, now we can close the session,
Any question?
Vasudev, I expect one question from you.
Sir, the
Yes.
renewable energy will be attached to the grid. So
Not directly to the grid, only the distribution. Distribution grid, yes.
How it will be connected, we can know that.
You have to
one.
connect to the common coupling point. Currently means if it is a classical grid, there 50 Hz is there, or 49.5 is there, or 50.2 is there. If we produce solar generation, then it is zero frequency. So the first job we have to install the polyelectronic device. We have to change from 0 to 50 Hz. That is available in the polyelectronics. That is the frequency control device. We will make it 50 Hz. Once we can 50 Hz, then this 50 Hz or the control variable 49.2 to 50 Hz, because we want to connect. If I want to get into the train, either train stops, I am in the stop state, both are in the rest state, or if the train moves slowly, I have to move slowly also. Because both the frequencies should be met, then only I can get into the train. That's the idea. Similarly, if I want to connect it, the frequency of that frequency, I have to manage the frequency of the solar generation, and thanks God, polyelectronics has advanced a lot. Polyelectronics will produce that frequency, and once we get frequency here from the solar generation, after conversion, anyone can connect it with that, no issue. You got my point? That is issue. That is a very simple thing. Actually.
That is simple, sir, but there is the, you can say there is the inertia. And
That inertia is a different inertia in case of a solar generation. If we go back to this diagram, yeah, this is the diagram. In the right hand side, you see this is called the inverter based generation, zero inertia. In the left hand side, the huge inertia is a 50 cycle per second, synchronous generator based. So, inertia issue will come only when the inertia is very low in case of a turbine. In case of a, I mean the wind generation, we cannot say inertia zero. That is rotating, but very slowly rotating. So either in case of low inertia or zero inertia, the biggest issue comes. So it's always better this turbine and coal-based generation. But the question is, coal will not be there another after 56 years. We have to think it. Coal generation, power generation with coal is the safest one. How many of these participants, including me, we use renewable energy source for our domestic purposes? CSC or state utility, they burn the coal, they give the power, we are having the meter and isolated inert, we put the plug and take the power because it is easier to get it. We will put the solar panel, we can, if I have a flat, I am having a huge space on the, I can put that solar panel and I can extend the power from that. But however, I did want solar panel there, but now it is not working. There is a huge problem with this. Wood panel, maintenance, cleaning dust, lot of issues. You have to change the battery. CSC is giving power by burning coal. That's the best way of taking. I will pay the money to them. Anybody from this depends on solar energy. I don't think so. A lot of issues are there. That is easier to get from coal. Burn coal, boil the water, generate the steam, throw the steam to the turbine blade, let it rotate, couple to the alternator, Faraday's law will act, voltage will be induced, make it close, Ohm's law will work, and power will flow to the conductor. That's all. As simple as that. So anyway. Yes, please.
Is it better if the renewable energy source is connected to the generating system side?
Renewable energy?
This renewable energy source
that's a question, but that I do not know how to define this question because renewable energy source, I saw somewhere it is not dispatchable. If sunshine is more in Sahara, it will be more in Sahara. You cannot ask sun, you give insulation more to Durgapur. But in case of a coal, if coal is available in Jori or in this side, I can bring coal where the load demand is more in Tarcher in Odisha, I can take there and do it. So as solar energy is not dispatchable, as wind energy is maximum available in seashore. Can I ask the people to produce wind energy in Durgapur where seashore is not there? It is not dispatchable. Where it is available from there, you have to take it only. You cannot change the generation side. That's the disadvantage. That's the disadvantage with the solar, the renewable energy. Geothermal, tidal, all you will get from the tides only. But in case of a coal, anywhere you can take it. Talcher is the maximum industrial area. So let us take coal through goods trade and there will generate it. But it is not feasible with the solar energy. The biggest disadvantage. Not only intermittency, it depends on location also. That's, if I am not wrong, I guess this is your question, I guess. You wanted to win or you wanted to win something else? I answered wrongly. What you wanted to win? The generation can be shifted by generation. In case of a renewable generation, you cannot shift. What God has given, you have to accept it gladly, otherwise leave me. If sun gives radiation more in Durgapur, you have to accept in Durgapur only. You cannot bring more insulation or radiation to Panagar area. What is available in Panagar, you have to accept Panagar only. That's all.
So we can keep damping renewable energy, inject kore damping.
Yes, just you say.
We are by renewable energy, injecting renewable energy. Shall I
We are not
increasing the
providing.
damping?
No, renewable energy is not a damper. Renewable energy is a generating source. That is, damper is a different kind of energy stand. Damper is a different issue. And the renewable energy is not a damper. Renewable energy is a source which will give you the power.
How we are increasing the damping? so that
You have to use the damping factor for that. Lot of damping devices are available. The way this damper is working in the door, lot of damping devices are available in the market. They have designed so that those dampers have to use. In case of that the classical generation only. Solar generation, no rotation, no questions of damping.
increasing damping, we are increasing the energy storage capacity.
Now, energy storage capacity is a different. That is not a damper. Energy storage capacity, if you increase, means if there is a demand, you can use it. That is the storage system. That is the storage. If there is, why do you keep the money in the bank? If the requirement is there, you spend from that side only. And that is that's why I told you there is a kind of a virtual inertia. This adding inertia to the system.
Wonderful lecture. Now I request our coordinator, Professor Sumit Banerjee sir, to appreciate a small token of appreciation.